Welcome to my channel, InnovaWorld. Today I'm gonna talk about aerospace research topic applicable for bachelor's, master's or doctorate program across the world. This video is made completely based on suggestions from experts and from the market survey. Before proceeding to the aerospace research topic, you must understand the sensible professionals like I-shaped professional, T-shaped professional, pi and M-shaped professional. So, I-shaped professionals are having a deep knowledge in a single or focused domain. For aerospace, focused domains like aerodynamics, propulsion, structures and manufacturing, materials and mechanics, design and control systems, space engineering or astrodynamics, then aviation management or aerospace medicines. Each individuals are considered to be as I-shaped professionals. So, T-shaped professionals means single or focused knowledge and collaboration across the domain. For example, how the applications of aerodynamics is widely implemented in supersonic, subsonic or even hypersonic field in the aerospace domain. Now talking about pi and M-shaped professionals are quite related to a deep knowledge or in one focused domain or implemented in multi-field domain. Moreover, it's like compiling a combo of aerothermodynamics, structures, controls into one research topic. For an example, aerodynamics and aerothermodynamics of re-entry vehicle. In this, you must have a knowledge of more than one domain like aerodynamics as well as propulsion is considered. So it will be considered as a pi-shaped professional. Today, I will discuss a possible aerospace research topic or the thrust areas based on I, T, pi and M-shaped professionals of each aerospace domain like aerodynamics, propulsion, structure and manufacturing, materials and mechanics, design and control, space engineering, aviation management and aerospace medicine. So let's start with applied aerodynamics, which covers a broad range of research topics both in aerospace domain as well as multi-field domain. Any research work on aerodynamics evaluated either through scientific computing, through CFD and numerical methods, or by means of experimental investigation. So the most possible topics are aerodynamic forces in fluid flow over a bluff body or any other body. Second comes unsteady flow or transitions and the turbulence or the vortex dynamics. So here you can see a few examples like numerical investigation of cavitation vortex dynamics in unsteady cavitating flow with a shock wave propagation. Then internal flow or a flow control. It can be either active or passive control of jets, like a large area simulation of a base drag reduction using jet boat tail passive flow control. Then aerodynamic shape optimizations. This is widely used in aerospace field. Like an example, effect of thickness to chord ratio on aerodynamics of non-slender delta wing. There are a lot many research you can do on the various configurations of the delta wing too. Then experimental fluid mechanics or wind tunnel techniques in subsonic or supersonic or even hypersonic field. Then helicopter aerodynamics. In helicopter aerodynamics, you can majorly do a research on rotor blade aerodynamics. Then separately research can be done on especially foreign blade aerodynamics. Then coming to an hypersonic aerodynamics. At present, much work is going on this particular field. Even missile aerodynamics, like an example, investigation of acceleration effects on missile aerodynamics using computational fluid dynamics. There are ample of research going on. Such amazing topic also you can pick, like effects of rainfall on an aircraft aerodynamics or the crosswind effects. Okay. Now I will tell you some of the aircraft aerodynamic concepts is applicable in other fields, like aerodynamics in wind power device, like comparison of the power, lift or the drag coefficients in the wind turbine blades or other the aerodynamic characteristics varying the airfoil. So then talking about the atmospheric flow or the wind aerodynamics. Again, some more precise research can be done on microfluids. Then aerodynamics of road vehicle like sports car or even high-speed train, bicycle. Actually, this is actually industrial applications of aerodynamics. There are a lot many research going on, like relevance of simulated parameters of a drag reduction in sports aerodynamics or even bicycle aerodynamics. Even the importance of unsteady aerodynamics to the vehicle dynamics. There are a lot many industrial applications are also going on. Then even marine vehicle dynamics, building or a bridge dynamics. You might have heard about the Tacoma bridge incidents. That is also further it has been studied about the bridge dynamics, and now we have made a better advancement in the research. All individual topics are I-shaped professional. Suppose any person combinedly working on blade dynamics along with the atmospheric flow and the experimental fluid mechanics will probably fall under the T-shaped professional. In upcoming talks, I will be giving you an example of how the research work can be compiled with other domains like propulsion, structure and so on. So stay tuned till the end of the video. Next, I will move to the propulsion research topic. Sometimes it is also called as thermal and propulsion core. So are as follows. In air breathing propulsion, now work on inlets, diffusers or nozzle for an various flight speed. Even advanced inlet and nozzles for subsonic, supersonic and hypersonic vehicles you can work on. Even combustion fuel flow reactions, it can also extend to a fire dynamics. Right? Then even turbo machinery, where work defines on the compressor and the turbine. If I talk about the rocket propulsion, now there are a lot many work going on in developing propellants like solid, hypergolic, monogolic propellants. Sometimes you can also it is also known as propellant chemistry. You can do a research on it. Then electric propulsion. Now talking about electric propulsion. Now microgravity, where the NASA is experimentally working on, and even CubeSat. All of you might be knowing. Even that is a part of electric propulsion. So then, talking about thrust vectoring, either a primary or the secondary, it is widely used in the rocket propulsion or in the space. Either we can talk about the rocket or the spacecraft. Then coming as the liquid atomization and spray combustion. This is also play a very important role. Similarly, you can also work on the modeling for the combustion instability predictions in rocket or even the gas turbine. Then heat and mass transfer plays a key role either in air breathing or rockets or the spacecraft or even in automobile industries. Then cooling techniques. When we are talking about thermal, there must be some kind of cooling techniques. It is very important. This also play a key role, and also cooling directly or indirectly plays a key role in efficiency. So another work you can do is a cryogenic application. There is a wide opportunities to work on cryogenic applications either in the engine or the fluid. You can work on by various means. Then another very special topic is a bio-inspired propulsion, like a biofuel. Basically, it is a pie-shaped professional, you can talk, where one need to have an idea about the vegetable oils or even aviation fuel and its composition. So there are a lot many research going on since 2005, I think, yeah. So even some of the industries, aviation industries are going on. You can see an example. Aviation CO2 emission reductions from use of alternative jet fuels. There are a lot more research you can do on it. But there are certain research topics okay, where the movement of air is crucial to both the aerodynamic vehicles and the efficient engine, that it can't be isolated from aerodynamics and the propulsion. Like some research has undertaken on civil turbofan engine exhaust aerodynamics. There are a lot many research is going on. Similarly, you can also take one of them. Then flame propagation and ignitions in boundary layer flow. Then multi-phases and the reactions to form in a complicated system, either in the form of gas liquid or the gas solid or the liquid solid interface. There are a lot many also projects are going on the CFD study of a single phase or the multi-phase pump mixture, or even if you talk about this rocket engine, when the cooling system is done in the cryogenic rocket engine. Okay, so talking about one more interesting thing is a vortex dynamics based analysis of internal cross flow effect in a flame cooling, how the vortex dynamics plays an important role in a cooling. This is also one of the advanced research topic you can take up. After propulsion, moving to an structure topic. So do not get confused with the materials. Materials I'll be explaining separately. So talking about the research topic on structures alone, it is a vast topic and many wide domains you can work on it, or we can categorize into it. Like you can work on the structural health monitoring, fatigue and damage tolerance of aircraft structures or components or the parts of aircraft, nut and bolts or whatever. Then morphing structures or multifunctional structures. Now this topic is highly working at present scenario, and I think this is the future. If you are specialized in structure, you must take up this topic and work on it. Now developing composite structures. This is also another developing composite structures. I think this is also another very highly demanded topic. Then coming to as experimental techniques to know the properties of structures or analyze of the structural failure. Then micro or nano finishing surfaces in multifunctional structures or in the general conventional structures. This also plays a very important role. In that, you can add up one pi professional, like you have one conventional one and you have made the same one with an 3D printing. And when you're making a finishing micro or the nano finishing, you can make a comparison data and you can bring up some research out of it. Then testing a structure through various entity techniques. This also can be performed, and let me tell you, this entity techniques are ample of entity techniques. You can take up one of the techniques and you can get the result. Keep in mind, in every case, you need to apply an adaptive finite element techniques and modeling tools or an experimental techniques to evaluate your results. Okay. Now, considering today's research on structures are more into an pie-shaped or M-shaped professionals, where the research work with aerodynamics, propulsion, material, design, manufacturing, controlling, so all are combined together. Let me highlight the more interesting and the present research progress or the nearing future. The oscillating airfoil dynamics play a key role of aeroelasticity topics. Even in morphing, some research has been undertaken, like composite additive manufacturing of an morphing aerospace structures. Okay. Now, talking about this additive manufacturing, now this is also one of the key role play in the structure group. This additive manufacturing structures compared with a conventional one. Like 3D printing technology has a wide scope to reduce the weight than a conventional manufacturing. Then, nanofluid for cooling thermal structure and its impact. Okay. Now, engine structure vibration due to instability combustions. Then manufacturing composites and smart materials and various type of processing. Then computational aero engine noise suppression. I have said, like, there are a couple of there is wide scope of opportunities to do research on this and pi professional. Then talking about a correlated topic with the structure is the aerospace material and the mechanisms. There are a wide variety of opportunities and the scope to work on, like a composite material and its mechanisms. Now, talking about mechanism, there are various forms like computational mechanics, experimental mechanics, multi-scale methods and the thermomechanics. You can work on any sort of mechanics of a material. Now, talking about next material is a nanomaterial. then high temperature material, then alloys such as aluminum based alloys, the magnesium based alloy, titanium based alloy, nickel based alloys, an ample of alloys you can work on. Then the smart and the multifunctional materials, chip memory alloys and the materials, then the magnetic data structures materials. Now this had a wide range of applications, or you can say PI professionals. Similarly, the electronic packaging materials. Then there are some various space materials like materials using battery to sustain energy for a longer period of time. One most very special and unique work you can do is a self-healing material. Now at present we are also doing a graphite base, but nowadays some more researchers are working on the bio-based self-healing material, because the fossil fuel resources are going to get exhausted or the oil price gonna rise. Now upcoming research is on bio-based self-healing material. Then our material machining processes, especially there are a lot many types, or the recent advanced in the development of the aerospace material you can work on. Then one more thing, a special material coating for the thermal insulation or the effective cooling. Now then also wide many opportunities, like to find out the mechanical behavior of an unique materials and the structure using an electronic microscope. Then study of a lattice structure or a bonding of particular materials. Study about thermoelectrical mechanical effects of material at an micro scale microstructures. Okay. Now study effect of metamaterials on an aeroacoustic properties, like an radar absorbent material. All of you might be knowing, most of the aerospace people will be knowing what is and where this radar absorbent material is used, called as a RAM material sometimes. Okay. Then multifunctional material systems to control the shock, vibration and the sound, like a damping assessment of a new functional materials, aerospace materials, which comes under the PI shift research professionals. Then bending mechanism for morphing aerospace applications. Then calculation and analysis of stealth and aerodynamic characteristics of various aircraft or the structures. This also play a very important or a key role in this also a type of a PI shift professional, where both the design knowledge is required, aerodynamics is required, propulsion and the material. Okay. Now after aerodynamics, propulsion, structure and materials comes the design. Okay, and it is a multidisciplinary domain which comes under the PI shift professional or an M shift professional, because here we need to know her idea about a computation analysis, numerical methods, where it need to transform and give an impact a new way of design. Okay, and sometimes it is being combined with the structure and design, or the design and manufacturing, or the design and controlling. Accordingly, I have been categorized into 4 forms. In cognition and the design theory, it is applicable for an modeling of any aircrafts or UAVs or airplane, or any mission analysis for a novel aircraft technologies, like mostly used in aircraft designs and aviation industries. Now talking about design automation, it is applied to an aircraft modeling and optimization of any aircrafts, UAVs, drone. Now basically what is drone? Drone is a dynamic remotely operated navigation equipments. Now here also when we talk about navigation, it is both we need a knowledge of a design as well as a controlling. Then artificial intelligence and the robotics will play a key role in this design automations. Now talking about sustainable design and efficient engine design for an fuel efficiency or compatible for a biofuel system. Such kind of design can be seen as a sustainable design. Now you can also work on recent advances in the fuel cell based on the propulsion system for an UAV, or mostly it is using UAV. There ample of research can be done on sustainable design. Now coming to a complex system design, this can be of the robotic arms, or maybe a landing gear mechanisms, or any other mechanisms, fuel tank design, landing gear systems, aircraft systems, maybe a hydraulic, pneumatic. Such kind of designs will fall under this complex system design. Okay. Now, looking close into another important field of control system alone in aerospace, where you can choose a strong multidisciplinary system oriented that emphasizes a linear and non-linear system, okay, and where also optimization, feedback control, optimal planning and decision making, then stochastic process, software aspects of flight systems. Now one must evaluate the computational and mathematical approaches through MATLAB and the Python in the most of the cases. Okay. Now looking here, this control system, here first of all the flight controls and the stability, a study on the stability and the performance of a linear and non-linear flight dynamics can be also involved in this topic. Then talking about the autonomous flight systems, avionics systems include space robots, multi-modeling sensors, then planning, it may be a structured or unstructured or uncertain structured avionics systems where you can maximize the information extraction from the sensor data, and you can accordingly make the decision and predict and monitor the health of this avionics system. There are a lot many work you can do on this avionics system. Then talking about the navigation system, to navigation system to any flying objects, talking from airplane, helicopter, even missiles. Then instrumentation is also play a wide role on this research field. Then dynamics and control of a manned as well as an unmanned air vehicle, there is an ample of research work. Now I want to highlight a special category is a non-linear system where it happens, where a wide variety of research can be done, like sensing and automation are integrated, where the stability and robustness is also switched to a new system, right? So this kind of work can be done, and additionally this kind of applications you can also involve like automation vehicle systems, maybe of fixed wing aircraft or underwater gliders or human flights and many more. Then as I've said, a few aerospace students can also enter to another specific topic like astrodynamics or the orbital mechanics, like space mission design, orbital debris in spacecraft and this approximately operators, asteroid deflection, flight plan operations, conflict detection and the resolution of nanosatellites and the space system. Talking about the space system, you can also work on the electrical propulsion system and making some small satellites for observing the earth and other whatever like in the solar system. So this all mostly comes under the PyShip professional are adopted. Then coming to us next is the aviation management. Now possible research openings in the aviation management. So here also mostly very few students do research on such kind of topics. So let us discuss that what kind of topics we can cover in this aviation management. Like you can do a research topic on the robust flight planning or air traffic management. Then how to make an air traffic management by avoiding of storms, okay, artificial intelligence applied in the capacity demand balancing, civil aviation airworthiness management, space tourism, service logistics and maintenance management, then supply chain and the air transport management, or even the aircraft manufacturing logistic you can work on. Very interestingly, recently I have been read an amazing research topic on integrating air and the nearing space traffic management for aviation and nearing space. If you are like even some more research in air and space laws, but that's are for the legal people, not for the engineers. Looking into the aviation or the aerospace medicine research, it is not for core aerospace engineering work, but mostly MBBS people are or the doctorate are working on such topics, and it seems to me quite interesting. So I thought I can share a pinch of idea about this space medicines. Like there's some more work has been done, like aeromedical solutions for aerospace safety, then aviation medicines, how the illness and the limitations for the flyers. Then at present we are into 2020 now, COVID-19 is going on. Like in this also I have read an article like COVID-19 patients with a respiratory failure, what we can learn from the aviation medicine. career options in aerospace and aviation medicine, that also you can learn. So as a nutshell, what I'm gonna say is, for each and every domain there are some drawbacks and scopes for future work. You can proceed as a research work. So I think it is going to be helpful for you to prepare your career according to your domain. So if you have any other further requested video, please do drop in my comment box. So stay tuned to my channel. See you in the next video.